Hey guys, another one-dimensional kinematics video. How high does it go? Okay, so in this question, a baseball is hit nearly straight up into the air with the speed of 21 meters per second. A, how high does it go? And B, how long is it in the air? Okay, so this question is going to frame future questions in that we have to start defining which direction is positive. Okay. So up till this point, we've always assumed that up is positive. And for the most part, working in a two-dimensional sense, up and to the right is considered positive and left and down is considered negative. Unless you define it differently. But nonetheless, it's always good practice to define it in your question. Okay, so I usually like to define up to be positive because it just makes things make more sense in my head. Okay, so this is how I define it. I write a plus in a circle and I show up. So that's the positive direction. Okay, so like I always start every single problem, now I'm adding an extra step to that. In addition to drawing a picture, you define your positive direction. Okay, so now that we did that, let's draw the picture. Okay, so we've got a baseball. Okay, it's going straight up. So it's almost straight up. It's going to curve and it's going to come back down, right? That's why it says nearly straight up. Okay, at some point it's going to be at the top when it stops, right? Because we want to figure out how high it's going. We know the initial speed, it's 21 meters per second. That's V naught. So you go ahead and label that in. Okay, we're looking for the distance from start to end. Now, just like the previous question, there is some information here that is not given, but you have to figure it out based on the picture or just based on the context. Okay, the fact that it starts with a certain speed and eventually gets to 0, which, by the way, is not yet labeled on the picture, so let's do that. Okay, so the final speed up here is V equals 0 meters per second. The fact that you actually get to 0 meters per second means that something was slowing it down. A change in speed means acceleration. And in this case, it's the acceleration due to gravity. So A is equal to, not just G this time, but minus G. Okay, so that's minus 9.8 meters per second squared. Very important that you include the minus, because if you don't, your values are not going to come out accurately. Okay, gravity is acting down, the baseball's going up, they have to have opposite signs. Okay, so let's go ahead and solve part A. Okay, so how high does it go? Okay, so we're going to go ahead and use this kinematics equation. 2AD equals V final squared minus V initial squared. Okay. Since we're looking for D, we're going to have to divide both sides by 2A. Okay, so that cancels out the 2A on the left, and you're left with D equals V squared minus V naught squared over 2A. Okay. So V is 0, simple. V naught is 21. Make sure you write the units, meters per second squared, divided by 2. A is negative 9.8 meters per second squared. Okay, so at this point, it's simply a matter of plugging it in the calculator. Okay, and you're going to get D equals 22.5 meters. Okay, so that's how high the baseball goes. Okay, so now as for how long it's in the air, this one's actually pretty straightforward. Okay, so we actually might have enough room to do it here. For part B, it all stems from the definition for acceleration, right? We know acceleration is the change in velocity with respect to time. And in this case, we're looking for just that, time. Okay, so if we rearrange this, we're going to get time equals delta V over A. Okay. If you multiply both sides by T, divide both sides by A, you're going to end up with this formula. Okay. Delta V is V final minus V initial. Okay, you divide that by A. Okay, V final 0, V initial is 21. That minus sticks there. Divided by negative 9.8 meters per second squared. And just notice there for a second, if we didn't have the minus in front here, you would have ended up with a negative time, which does not make sense in this context. Okay. When you solve it, you're going to end up with 2.143 seconds, and I'm going to round that to 2.1. Okay, so 2.1 seconds is the time. But here's the thing, that's not how long it's in the air. And if you're wondering why, take a look at the picture again. Okay, so we figured out the time it takes to go from this speed to 0. 0's at the top, which means the speed that we just found, 2.1 seconds, is the speed for it to go from here to here. Okay, that's half the time. In order to get the total time in the air, we're gonna have to double it. Okay, so when we double it, we're gonna end up with t equals 4.2 seconds. That's how long it's in flight. Okay, so in fact, the time is accurate to the correct number of sig figs. In terms of the distance, it actually isn't. We should round this. Okay, so from 22.5, let's actually round that to 23 meters, right? We only want 2 sig figs. And there you guys have it. We've got the distance, we've got the time. Okay, so that's it for this video, guys. If you liked it, as always, please give that like button a click. Subscribe to my channel for more physics videos, and stay tuned because I'm going to be uploading frequently. Okay. As always, if you guys think this can help someone else, feel free to share with them on Facebook or Twitter. And that's it for today, guys. I'll talk to you later.